I'm Ben Lanz, Executive Advisor for APC Media, Power Systems Technology Magazine. We're here at IEEE Grid Edge in San Diego, California to interview thought leaders in our industry to hear their insights into the challenges that we've been facing for the last couple years and what do we need to be working on. Through these interviews, we're going to bring their insights to you, our readers. I hope you enjoy. Our next guest is Scott Brodenkircher. Welcome.
Ben, thank you very
Arizona
much.
Public Service. You're Director of Wildfire Management? Help me out.
Forestry and fire mitigation.
Forestry and fire mitigation. Well, it's great to have you here at Grid Edge. I know you're on a panel yesterday afternoon that was very well received.
Thank you.
With all of your experience with fellow utilities, was Encore and San Diego Gas and Electric, as well as somebody from Cal ISO. And that was, again, utilities. I heard many comments about the practical experience that you were sharing. But tell me a little bit about your current role and a little bit about yourself as you work with. How long have you been with Arizona Public Service?
So I've been with Arizona Public Service 20 years now.
20 years already.
Yep,
Okay.
Yep. Many different positions.
Okay.
Background in technology and technology innovation and kind of looking at things differently. Parlayed that obviously then into operational roles throughout the company, and my latest role being over forestry and fires. And so in this role, responsible for all of our vegetation management programs, standard right-of-way clearing, NERC compliance in terms of transmission line spacing and clearance on those. And then, of course, the big one for all of us utilities these days, fire mitigation. So all of our fire mitigation strategies, activities, our comprehensive wildfire mitigation plan, overseeing that and the execution, that's all part of this role.
That's remarkable, all of that responsibility. And when you started with APS, did such a role even exist?
No, it did not. Of course,
Okay.
we had the forestry department at that point, but certainly wildfire, while I'm sure was something that folks thought about from the standpoint of trees and vegetation hitting lines, it was certainly much more from the viewpoint of reliability and obviously causing outages on those lines versus something like a catastrophic wildfire.
Right, so now we're not only talking about reliability, but we're talking about resiliency and sustainability. You know, what kind of investments are we going to make, and can we sustain that level of investment?
Correct.
And the resilience in the face of these greater threats and challenges, in addition to reliability, because you still have to have reliability. So, having said such, the challenges that you've seen over your career here, the 20-year career, just at APS, never mind from the technology background that you said you had, what are some of the challenges at the grid edge that you've seen that the industry is doing well, or that you've seen solved in your career?
So I always hesitate to answer the solved question, because I kind of feel like many things that we do, we've never quite arrived. We're not ever really done yet, but clearly we've made fantastic strides on data acquisition at the grid edge, controlling devices at the grid edge, a lot better interaction with customers from things like AMI smart meters and those types of devices, a lot better control over our distribution system from the standpoint of SCADA enabled switches, reclosers, relays, capacitor banks, all of those types of kind of smart grid technologies. We've made tremendous strides. I think the grid is much more resilient, much more reliable than ever, simply because we have a lot better real-time situational awareness of what's going on.
Situational awareness, good word.
And of course, then we have the ability to reach out and touch those components too when we need to. So to be able to facilitate switching lines in and out, bypassing faults, things like that, and understanding where they occur.
Sure. Wow, that's. I can see how you're saying the actual situational awareness. I'm coming back to that, because if we don't know what's going on or what the problems are, how are we supposed to make prescriptive recommendations, let alone actions? So
right.
I can definitely see how that can be a real positive impact to the grid. But now,
and that's a big thing then, especially in today's world of my current role of fire mitigation, right? And so understanding what's happening on those lines, where those faults are occurring, I mean, that's part of our first defense in understanding, do we have issues out there that could potentially contribute to wildfire? And so making sure that we're aware of those, and then being able to turn off power or reroute power or deal with those as quickly as possible is really key to even this current role.
Right. So we've done a good job at with visibility, with information, with being able to respond quicker. What are some of the things that you're doing at the grid edge to mitigate the risk? What are you doing to actually, if such an event exists or happens, how do we prevent it from making other challenges, like from a resiliency standpoint of the grid, or even ignition scenarios?
So first and foremost, of course, and we've just talked about it, which is knowing about it, right? Can't do anything until we know about it.
Right.
The sooner and quicker we know about it, the sooner and quicker we can handle it. And I think one of the things, obviously, that's pervasive across this conference and really in the public thought right now is artificial intelligence and AI. And so us being able to push that down to the grid edge, use our awareness of situation, and then use automation, machines to be able to make much faster decisions than a human can and interact with those components, and therefore not only increase reliability and resiliency, but also then be able to more quickly deal with catastrophes, emergencies, things as they come up.
So would that be like automated switching that shuts off certain components if it identifies a risk?
Yeah, it could be automated switching. Could be just simply relays that take out lines automatically when they need to because they sense a fault on the circuit.
Ah, right. So perhaps not a dead short, but something like a high impedance fault or something like that. Ah, okay, yeah, I can see that. I'd like to ask one follow-up question. What about, the fire starts, and in many cases I understood from the panel session that this is not just a utility challenge. This is a societal challenge, right? Because we have landowners, we have homeowners, there's other assets that could be the source of ignition or the source of fuel that brings it to the power grid. And I think you said something like, of all the forest fires or the wildfires, it's what percentage?
So it varies by area, but it's a very, very, very small percentage. I mean, it is certainly way south of 10%, right?
Okay,
and so you think about the human-caused fires, you think about lightning strikes everywhere throughout mountainous, forested terrain. That accounts for a far, far greater percentage of wildfires in general. And so, to your point, as much as it's our responsibility to protect against the electrical grid actually potentially causing one of those fires, we need to protect the grid from those fires when they start from other sources.
Right. So if I may ask, what are you doing to help the grid be more resilient when the fire's there?
So we do a couple things from a very physical protection basis. One is we have a defensible space around poles program, where we actually do a 10-foot clearing radius around all of our equipment poles, and that not only helps in case something happens on our pole that might cause sparks to fall and cause an ignition, but then obviously you've got this barrier of clear ground. As fire approaches a pole, it doesn't then cross over and burn the pole down. We've got a big program around actually trading out wood poles to steel poles, which obviously are therefore much more fire resistant. And then lastly, in places where we still have to use wood poles, we're utilizing a pole wrap around those poles that actually insulates and protects that pole from fire burn as well.
Wow. Okay. So you have quite a few tools in the toolbox, and I would imagine some type of Pareto analysis to figure out what tool goes where, because that's get a lot of tools in the toolbox. That's great. So I want to move over now. I want to switch gears here and think about going forward, the next 3 to 5 years here. At the grid edge, what do you see as some of the challenges that we yet need to solve, or maybe completely solved, something that we haven't completely solved yet, we need to really work on to finish it up or get it to a certain level of capability, or something that we're really not thinking about and we really need to from an industry standpoint?
So I think if I concentrate right now just on the idea of wildfire mitigation, and then we can kind of look at other areas, but from a wildfire mitigation perspective, one of the number one things we need to know is, do we have broken equipment? Do we have a line on the ground? Because that's the biggest chance where our facilities could potentially ignite that fire. We have technologies now that sense a fault or a high impedance fault and will shut power off. but that could still be a tree branch. It could still be a child's kite. It could still be something that doesn't necessarily mean that a fire is going to start. And so to me, really cracking the nut of how do I absolutely know that wire is on the ground versus some other kind of just transient occurrence has happened in that area. And so then I know for sure, do I shut the power off or do I not? Phoenix, Arizona this year, well, last year now, had over 150 days of 100-degree weather.
Wow.
So turning off the power under any circumstances is never an easy decision for us.
Right.
We obviously make the decision when we have to because of greater worries about safety, whether it's wildfire or other things, but it's still something that potentially puts our customers in jeopardy because of the extreme heat. And so cracking that nut of being able to truly know, yes, I've got a wire on the ground, now is the time to turn off the power, that to me is key. And I think that's going to take a lot of additional work in the AI front. It's going to take a lot of additional work in sensors and the sensitivity of those sensors, as well as then that capability to match those patterns and understand when you've got that condition. As it relates to non-fire mitigation things, I think one of the biggest, to me, benefits of grid edge technologies has always been that customer interaction. So how do I take engagement with us as a utility closer to the customer? And we've looked at some of those things and talked about some of those things for several years around smart metering and AMI. But we're really now kind of in that first generation of those meters where we have actual computing running at that grid edge, running at that house. So I really look forward to seeing what us and other utilities now do with that power in terms of whether it's small apps for the customers to use and understand their energy use, potentially be more efficient in their energy use in homes. And so to me, that's a really exciting area because I think it's a whole nother level of kind of reaching out to our customers versus just going to a website or getting a bill in the mail.
Right. Well, that's fascinating. That's certainly a large area that we can work on, and there's a number of vendors here I know that are working in areas there, but I can see a huge growth in that area. A question about Grid Edge here. This is, I understand, your second time at Grid Edge. Yeah. So, why are you coming back? I mean, what is the value that you see at Grid Edge?
So one of the things I really enjoy about this conference is it brings a lot of companies together that are truly on that cutting, bleeding edge. I was privileged enough to participate in a panel session yesterday, but I've been in many other panel sessions and presentations while I've been here by national labs, thought leaders at universities, really, really smart engineers, of which I am not one. And so being able to hear from them what they're concentrating on, what they're working on is just an amazing source of learning, an amazing source of things I can take back.
It's a pretty big cross section of the people who are focused on the Grid Edge. Yeah, that's great. Well, Scott, any further comments and closing remarks to our readers that you'd like to share?
Well, thank you very much for having me. I very much appreciate that. I'll start with that. But then, I think, and I almost feel like we're starting to say this almost every year, but I still feel like it's completely salient, which is we are in such a changing time for our industry and for utilities and for energy in general. That I just am really, really excited by events like this and by all of the work that's going into how we improve that resiliency, how we improve that reliability, how we solve those problems. Because in the coming years, when you look at needing and changing energy needs, data centers coming online, the need there, again, back to AI, we have some really difficult problems that we're going to need to solve. And so this is a great cross-section and a place to be here and see people directly attacking those problems.
Well, Scott, it's been great to have you. Thank you for all your insights.
Thank you.